Today we're going to be going over polynomial and other nonlinear graphs. While these are only worth 7 points on your average SAT, they've definitely been worth more on some, and so make sure you know this concept. Our approach on these is going to be to identify polynomial and other nonlinear graphs questions. We're going to break down the question, we're going to build a formula to solve them, and then we're going to solve a practiced question together. So how do you identify these? Well, these questions kind of cover all graphs that aren't linear or quadratic. So if it's not linear or quadratic, it's probably in this concept. There's a few that aren't, like exponential graphs aren't, but most graphs that aren't these two are going to be in this concept. And what they're going to ask you about typically is roots or end behavior. So here's going to be our formula for polynomial and other nonlinear graphs. Step number 1, we're going to understand what is asked. Step number 2, we're going to analyze our graph/equation. Step number 3, we're going to apply what's asked to this graph/equation. So here's an example problem. It tells us that the function f is defined by f of x equals x minus 2 times x plus 4 times x minus 3. And then says in the xy plane, when the graph of the function f, where y equals f of x, is shifted up 8 units, the resulting graph is defined by the function g. If the graph of y equals g of x crosses through the point 5, b, where b is a constant, what is the value of b? Okay, so a lot of words in this one, but let's just break it down to what's important. So we have our graph here, and then we're shifting it up 8 units, and that's asking us after shifting it up 8 units, what is the point at 5, b? And so that's what it's asking us. So what I'm going to do first is I'm going to shift our equation up 8 units, and if we remember from our translations, when you do f of x plus 8, that shifts a graph up 8. And when you do f of x minus 8, that shifts it right 8, and vice versa for these. And so for this top one, if it would have been minus 8, we would have shifted down 8. And for this bottom one, if it would have been plus 8 inside the parentheses, that would have shifted us left 8. So after reviewing this, I can just rewrite our original equation as f of x equals x minus 2 times x plus 4 times x minus 3 plus 8. And that's shifting our entire graph up 8 units. Now, once I have this, I can just plug in 5 for our x's and we can get our answer. So f of x equals 5 minus 2 times 5 plus 4 times 5 minus 3 plus 8. And then lastly, it's just 3 times 9 times 2 plus 8. And so for this one, I'm getting 54 plus 8, or 62. And as we can see, that's correct. Now let's plug this one into Desmos and see if Desmos can do all this work for us. So I actually plugged in our original equation, which is this black graph. And what Desmos lets you do is if you define f of x, you can just write in the next line f of x plus 8, or whatever translation you're doing, and it'll graph that as well. And so that's what we see in this red line. Now I'm just going to plot point x equals 5 so we can see where it intersects this red line. I'm going to scroll in to where it looks like these two might intersect, right around here. And it's telling us, hey, here's the intersection point, 562. So as you can see, Desmos was a quick and accurate way to get the answer on this one. So definitely use Desmos when you're tasked with these tricky graphs. It's going to be really useful. It's going to help you get the answer so many more times than you would have just doing it the mathematical way. And so make sure you're utilizing both the math and Desmos because they're going to help you get full points in these graph and very equation heavy concepts. So definitely use Desmos and good luck on these.